Mr. Sutton here, bringing you the IM3 Chapter 2, Quiz 2 Extra Practice Number 2 solutions on review of advanced factoring techniques. There's a puzzle that goes along with this one. Let's go take a look at that. So here's the puzzle that goes along with that extra practice. We're trying to solve the riddle, what do you call a sore on a police officer's foot? So the idea here is we've got two sets of problems, 6 in each. We have to factor these completely and then check to see if we have an answer that matches that down below each set of those. And then we just put that letter next to the number of whatever problem it went with. So for example, let's say I do number 1 and I figure out that the answer is, I don't know, O. I don't know. Maybe it is. We would put an O next to 1 down below here. All right, so let us proceed. All right, so here we go with problem number 1. We have 3x squared minus 15x plus 18, and we're trying to figure out what that factors into. So if I don't have an x squared by with a 1 next to it right away, I'm always going to try to take out a common factor, and if that doesn't work, I've got the AC method I can try. I've got some perfect square shortcuts. In this case, I see that all three of my coefficients, 3, 15, and 18, have a common factor of 3 that I can take out. So let me factor a 3 out of all of that. That'll leave me with an x squared minus 15 divided by 3 is going to be a minus 5x. And then 18 divided by 3 gives me a plus 6. And now I can factor the things inside my parentheses. Inside I just have a 1x squared, so I can go to my easier factoring technique. I'm just looking for factors of 6 that add up to negative 5. So let me think. 1 and 6 doesn't work. 2 and 3 works if they're both negative. So I have the 3 that I took out already, an x minus 2, and an x minus 3. Looking over here on the left to see where that is, I see that that actually is choice O. I didn't even mean to pick the right answer when I was going over how to do the puzzle, but apparently I did. You know, stopped clock is right twice a day, so we're going to put an O next to number 1 here. On to the next problem now. For this one, I have an x cubed. These all actually have an x, so I can take a common factor of x out of all of these. In fact, I'm going to need to do that. So that'll leave me with an x squared, and then everyone just has one lower exponent on x, so this is a plus 11x. And the x's with the 10x cancel completely, so that's a plus 10x, or just 10 actually. Now for the stuff inside, since it's just 1x squared, I'm looking for factors of 10 that add up to 11. Well, 1 and 10 works, so I have the x that I took out, I have an x plus 1, and I have the other factor, x plus 10. Looking over here for that answer, I see that in choice E, so I'm going to put a E next to the 2 down here. Now number 3, it looks like we only have 2 terms here, and they both have x's, so I can definitely take out a common factor of just x. But also, 8 and 18 are both divisible by 2, so I'm going to take a 2x out of all this. So I have 2 and an x, and if I take that out now, this is going to be a 4x squared, and then dividing that into the negative 18, divide that by 2x, that's going to be a negative 9. Now the stuff inside, 4x squared minus 9, you might notice these are both perfect squares. So I can use my a squared minus b squared shortcut, where we basically square root each thing and put in a plus and minus parentheses. So I've got the 2x that I initially took out. The square root of 4x squared is also going to be 2x, and then plus 3 for my b term there, and then I'll have a 2x minus 3. Finding all that over here on the left, it looks like that's going to be an n, so number 3 then is n. On this next problem, I noticed that all 3 of my terms have an x in them, so I can definitely take that out as a common factor. And also 5, 40, and 60 are all divisible by 5. So I can take out a 5, I can take out an x, and now let's see what I have left in my parentheses if I do that. 5x cubed divided by 5x, 5's cancel, x cubed over x is just x squared. And then negative 40 divided by 5 is negative 8, x squared divided by x is x. And then for this last term, 60 divided by 5 is 12, and the x's cancel, so plus 12. Inside, I just have a 1x squared situation. So let me just find factors of 12 that add up to -8. 1 and 12 doesn't work. 2 and 6 will work if they're both negative. So I have the 5x that I took out. I have an x minus 2. And then I also have an x minus 6. And all of that stuff, it looks like, is going to be down here with an O. So number 4 is getting an O. On this one, I see that we have a non-1 for the x squared coefficient, so I'll try to take out a common factor. 4, 8, and -60, I think 4 goes out of all of those. That leaves us with an x squared plus 2x minus 60 divided by 4 is 15. I have just a 1x squared inside the parentheses, so let me just figure out factors of -15 that add up to 2. So let me see, 1 and 15, nope. 3 and 5 works if we have -3, +5. So I have the 4 that I took out initially. I have the x minus 3, and now I have an x plus 5 as well. So that gives me, let's see here, I see that combination under choice C right here. So let me put a C under number 5. That's over here. First letter of the solution of the puzzle. This next one, it looks like we have an x in everything, and also everything's divisible by 2. So let's start by taking out a 2 and an x, dividing each of these things by 2x. 2x cubed is going to become an x squared. And then this next one, -20 divided by 2 is -10. X squared divided by x gives us an x. And then finally, -48x divided by 2x, that's going to be a -24, and the x's cancel completely. All right, the stuff inside that parentheses, we have an x squared with a coefficient of 1. So that means that we can just ask for two numbers, two factors of -24 that add up to -10. Well, let me think. 1 and 24 won't work. 2 and 12. 2 and 12 would work, I think, if we had a +2 and a -12. That would add up to -10. So then we have the 2x that we had initially. We have an x plus 2, and we also have an x minus 12. Looking over here on the left to see what that matches, it looks like we've got an h, and this was problem 6, so we have 6 getting an h. For number 7, we have a coefficient of m squared that does not look like a 1. So that means we either need to find a common factor or AC method or something. So it looks like all of my coefficients, 4, -18, and 14, they're all even. So at the very least, I can take out a 2. It's not as much as I would like to take out, but if I at least start there, the stuff inside should be a little easier to factor, and I have to take it out at some point anyway. So that leaves me with a 2m squared minus 9m plus 7, 14 divided by 2. And now for the stuff inside, I'm going to have to use AC method for this. So this 2 times this 7 gives me an AC value of 14. And then I'm looking for factors of 14 that add up to -9. Well, -2 and -7 would do it. So I can split up this -9m into -2m and -7m. So let me go ahead and do that. Next up, I'm going to factor by grouping. So in here, the first two terms, 2m squared and -2m, I can take a 2m out of both of those. And then that leaves me with an m minus 1. For the next two terms, since the third term here is negative, I'm going to take out a negative, and I can take 7 out of both of those, which is kind of nice. So take out a -7, that leaves me with a positive m and a -1. Next up, I notice in here I've got this duplicate parentheses of m minus 1. So in addition to the 2 that I took out way in the beginning, I have a common factor of m minus 1 coming out of everything. And then that leaves my leftovers 2m minus 7 for my other parentheses. Looking to see that on the left side here, I've got a 2m plus 1. That's not what I want. It looks similar, but that's not the one I wanted. It's a little bit different. Let me keep searching. Here we go. 2m minus 7, m minus 1. So that means 7 here, box 7, is getting an n for that one. Moving on to the next one, it looks like all of these terms are divisible by 3. So at the very least, I can take a 3 out of all of those before I try any more advanced factoring things. And they also all have an m, at least m to the first power. So let me take that out as well. So my first term, 15m cubed divided by 3m, that's going to be a 5, and then m squared is going to be the result of m cubed over m. For the next one, 24 over 3 is plus 8. M squared over m would give us m. And then the last term, 9m divided by 3m, that would be a 3, and the m's cancel completely. Now for the stuff inside, it's not pretty, but I'm going to use AC method, and it'll at least be easier than if I left this 3 hanging around in there. So 5 times 3, this 5 times this 3 gives us an AC value of 15. Now I need factors of 15 that add up to this 8 in the middle. 1 and 15 won't work, but 3 and 5 does. So I can split up this 8m into a plus 3m plus 5m. All right, let me go ahead and use some factoring by grouping on that stuff in the parentheses. So for my first two terms, 5m squared and 3m, all I can do is take out an m. So I've got the 3m that I took out initially, and now I'm taking out this m inside here. That leaves me with 5m plus 3. Next, 5m plus 3 over here, I can't take anything out of there other than a 1, so let me do that. Leaves me with exactly what we have here, 5m plus 3. But that's okay because that matches the 5m plus 3 that we already got by taking out that m earlier. So factoring everything now for my last step, I've got the 3m that I took out in the beginning. I've got this common factor of 5m plus 3 that I can take out of everything. And then this m plus 1 leftovers gets its own parentheses. Going over to the left to see where I got all that, that's actually the very first letter, O, so 8 is an O. For number 9, we've got 15m squared minus 10m minus 25. Those are all divisible by 5, so I can at least take a 5 out of all that. So that'll leave me with 3m squared minus 2m minus 5. And for the stuff inside here, I can use my AC method to factor it a little bit more maybe. Let's find out. So we have 3 times negative 5 giving me an AC value of negative 15. And then I need factors of negative 15 that add up to negative 2. 1 and 15 doesn't work, but 3 and 5, if I have a positive 3 and negative 5, that'll work. So let me split up this negative 2m to be a plus 3m minus 5m. And now that I've got 4 terms in there, I can factor this whole thing by grouping. So we've got the 5 I took out in the beginning. Out of these first 2 terms in here, 3m squared and 3m, I can take a 3m out of both of those. So that leaves me with an m plus 1. And then for negative 5m and negative 5, I can take a negative 5 out of both of those, leaving me with a positive m and a plus 1. Going back now, I've got this 5 again. I took that out in the beginning, and I don't want to lose it. I also have this m plus 1 common factor coming out of everything. And then finally, I have a 3m minus 5 leftovers parentheses. Looking over on the left to see where I've got all that, S here looks similar, but it's a little bit different. We want 3m minus 5, not 3m plus 1. So let me keep going. Down here, T, we've got the 5, we've got the 3m minus 5, and we've got the m plus 1. So then number 9 is getting a T. This next problem, let me see first if I can take any common factors out of all this. So 50 and 2 are both even, so I can at least take out a 2. And they also both have an m here, so let me take one of those out. 50m cubed divided by 2m, well 50 over 2 is 25. M cubed divided by m is m squared. And then negative 2m divided by 2m, well that's just minus 1. And now I'm noticing inside that I've got 2 perfect squares with a minus between them. So I can use this a squared minus b squared shortcut, basically square rooting each thing and having a plus and a minus parentheses. So I've got the 2m that I initially took out, and now for my first parentheses, this is the a plus b, I've got the square root of 25m squared. That's going to be 5m plus the square root of 1, which is also 1. And then I also have a 5m minus 1 for the a minus b part of this. Now that I've got this fully factored, let me see if I can find that over in the answers. It looks like it's down there. This is going to be a p going in spot number 10. Number 11, looking at this expression here, it doesn't look like I can take out any common factors, so I'm going to go straight to AC method on this one. 3 times 8 gives me 24 for my AC value. And now I need things that multiply to give me 24 and add up to negative 10. 1 and 24, 2 and 12, none of this is working so far. 3 and 8 doesn't work either, but that's close. 4 and 6 works. So if I have negative 4 and negative 6, that'll add up to negative 10. So I'm going to split my negative 10m up into a minus 4m minus 6m. And now I can use factoring by grouping since I have 4 terms. Taking an m out of the first 2 here, because that's all I can take out, I've got a 3m minus 4. And then for my second 2 terms, the third one's negative, so I'm going to take a negative out. And then it looks like I can take out a negative 2 from both of those. They're both even. So I'm going to take a negative 2 out, leaving me with a positive 3m. And then 8 divided by negative 2 is negative 4. So I can take my common factor of 3m minus 4 out of everything now, and then I have leftovers of m minus 2 for my other parentheses. Taking a look at my answers to see if I can find that, there's not too many of these that don't have something out in front, but this one doesn't. 3m minus 4, m minus 2, that's an r, so 11 then is going to be an r. For the final problem, number 12, these look like some fairly big numbers. The good news is it looks like I can take a 6 out of all of these, and also an m. So 60m cubed divided by 6m, that's going to be a 10m squared. 54 divided by 6 is 9, and then m squared divided by m is just m. And then negative 6m divided by 6m is minus 1. That wasn't so bad. The stuff inside, however, is going to need a little more work. So because I'm starting with something that's not a 1m squared, it's a 10 out in front there, I'm going to use my AC method. I probably could do this another way. Since I've only got a 1 over here, I feel like I don't need to go full AC method, but I'm going to do it anyway. So 10 times negative 1 is negative 10. And then I need numbers that multiply to give me negative 10 and add up to positive 9. So I'm thinking negative 1 and positive 10 will do that. So let me split this up. I've got the 6m initially, and now negative 1m plus 10m. And let me use some grouping on that stuff inside since I've got 4 terms. So I had the 6m out there initially, and then for the first 2 terms, 10m squared minus m, I can take m's out of both of those, leaving me with a 10m and a minus 1. For my next 2 terms, 10m and minus 1, I can't take anything other than a 1 out of those. So that's what I have to do. And that leaves me with, well, the exact same thing I started with, 10m minus 1. Next, I've got my factor of 6m that I took out in the beginning. Don't want to lose that. But now the stuff inside, I have a common factor of 10m minus 1. I'll take that out of everything. And now I have these leftovers of m and positive 1 that I can put in the parentheses next to it. So looking for all these results, 6m, 10n minus 1, m plus 1. I see that right down here. That's a C. So 12 is getting a C. And now we've completed all of the missing letters. We can go ahead and solve the puzzle. So the original riddle was, what do you call a sore on a police officer's foot? And looking here, it looks like the first word is going to be corn. And then we have O-N, that's on, T-H-E, that's the. And then our last 3 letters, C-O-P, that spells cop. So corn on the cob, kind of like corn on the cob, I guess. All right, cool. This is Mr. Sutton signing off.